Hi, I'm Jimmy, aka Perceptes. In this video, we're going to look at a small but complete Euro rack modular setup for making gritty, atmospheric techno. Modular setups can get very big and very expensive, but there's plenty of fun to be had with a smaller system, as long as you have a goal in mind and a cohesive plan for which modules to use together and how. First, we'll cover the goal for the system. Then we'll discuss what each of the modules do and what role they play in achieving that goal. And then, of course, we'll get to patching and making some music. If this sounds good to you, stick around. The goal of this system is improvised techno. I want something with a generative melody and generative modulation sources that gives me some ability to control and perform techno with a 4-on-the-floor kick and two closely related melodic voices passing through an atmospheric delay and reverb effect. Noise engineering is very well known for their oscillators that respond really well to modulation, and so that's going to be the core of our patch, modulating our noise engineering oscillators and creating a lot of different sounds from the same small number of modules. As you can see, this case is almost entirely noise engineering modules, with the exception of Pamela's Pro Workout on the left, which is going to be our clock source and one of our modulation sources driving the rest of the patch. Let's go through the modules one by one and explain their role in the system. The core of the system is these two modules here, Bassimilus Iteritas Alia and Incus Iteritas Alia. These are two different firmwares for the Alia platform of hardware, where you can buy one of them and then flash any of the other firmwares into the series onto the module with a USB cable in your computer. Bassimilus is a very popular and well-known oscillator that uses additive synthesis to create a lot of different sounds, generally focused on drums, but also with the ability to create melodic voices as well. Incus is a newer firmware that's very similar and has controls that are roughly analogous to Bassimilus. We're going to use those two in combination to create a big fat stereo field that plays the same melody but has different timbral qualities that can be modulated independently. We're then going through Electus Versio, which is going to be our sort of combination delay and reverb. This is a Versio platform module that's similar to Alia in that you can flash multiple different firmwares onto the same hardware, but is focused on effects rather than sound sources. Desmodus is the most popular Versio firmware, which is a very nice reverb. Electus is a version of it that's very similar, with the exception that you can clock it. So it has this tap input, and you can send that a clock signal, and then the delay lines that are the basis for the reverb can be synced to the tempo of your music. Our last sound source is Timpleggio here on the right, which is a percussion synthesizer and another platform module from Noise Engineering that allows you to flash multiple firmwares onto it. Timpleggio is one that's focused on drums, and we're going to be using that for a very straightforward techno kick drum. You'll notice that there isn't a mixer in this case, and that's intentional. Part of what you have to think about when you're designing a small case like this is trade-offs. What are you going to include in your case, and what are you going to omit? You could always do more by adding more modules, but with a small case, you have to decide what are you going to leave out in order to make the most of the space. So the way that we're going to combine the voices here is we're going to take the output of the two Alia modules, which are each mono, and go into one of the two channels each on Electus Versio, because Electus is a stereo effect. So that's going to give us sort of a single voice with one oscillator in each channel. We're then going to go out of Electus Versio in stereo into the input of Timpleggio, because that has a stereo audio input as well as stereo audio output. And this is really handy. What this does is it passes through the audio that's coming in, but every time the drum is triggered on Timpleggio, it will duck the audio that's coming in to allow the percussion generated by Timpleggio to have some room to breathe. So this will automatically give us that sidechain compression pumping sound that we want in this type of music. The left side of the case is our sequencing and modulation. Pamela's Pro Workout is going to be driving everything. We have it set to 140 BPM, a nice speed for techno, and we're going to be using its outputs to clock Mimetic Digitalis, which is going to be our modulation sequencer, Electus Versio, so that our delay and reverb is synced to the beat, as well as the pitch sequencing for the two oscillators. Mimetic Digitalis is going to be our primary performable modulation source. It's a CV sequencer that has 4 channels of 16 steps each, which is represented by this grid of LEDs on the panel. On each step, you get a different value between 0 and 5 volts, and you have 4 channels of that. You send it a clock, and every time it receives a clock pulse, it advances to the next step. We're going to send those 4 channels of CV modulation into the Lapsus Os, which is a 4-channel attenuator and inverter. And the Lapsus Os is going to allow us to perform in real time how much of that modulation signal we want to let through to affect the 2 oscillators. Okay, I think we're ready to start patching this up. Let's start with our audio flow. I'm going to plug in our final output, which is Timplegio. That's a stereo output that's going into our audio interface. And then we're going to plug the output of Electus Versio into the input of Timplegio in stereo. And we're going to plug Basimilus and Incus into the left and right inputs of Electus, respectively. Now let's patch the triggers for our 2 oscillators. Both Alia modules have built-in amplitude envelopes, so you don't need a VCA. You can just plug a trigger signal into them and they will automatically create a voice. So let's use the first 2 outputs of Pamela's Pro Workout to trigger those internal envelopes on each of our oscillators. I'm going to set the clock division of both of them to 2x, which will give us an eighth note rhythm. And because they're the same, we could technically use the same output and just send it through a passive multiple. But I want to keep them as separate outputs on Pamela's Pro Workout so that we can actually change the clock division of one or both of them on the fly to separate them from each other a little bit. On the third output, we're going to plug in the trigger for Timplegio, which is our kick drum. This is just going to be 4 on the floor quarter notes. The fourth output, we're going to set to 4x, which is 16th notes. And this is going to be our clock signal that is going to sync Mimetic Digitalis and Electus Versio. So I'm going to plug in a cable with a passive mult, and we're going to send 1 copy of the signal into the N input on Mimetic Digitalis, which is going to advance the position of Mimetic. And we're going to send 1 copy into the tap input of Electus Versio, which is going to sync our delay and reverb. So if I start the clock, we should hear our melodic voices and our drum. We can turn up the dry wet and the feedback on Electus Versio to start to hear that atmospheric reverb. Great. Now let's patch up a pitch sequence for the 2 oscillators. I'm going to take the 5th output of Pamela's Pro Workout and plug that into the pitch input on Basimilus. This is just currently a quarter note clock that's alternating between 0 and 5 volts. We're going to change this to a 4x multiplier so that we get a new pitch on each 16th note. That's 2 pitches per 8th note of the trigger. We're going to go into the advanced settings. We're going to change the shape of the wave to the stepped random, which is going to give us random pitches. And then we're going to change the level of the output to 20%. This is a percentage of 5 volts. So if we set this to 20%, then we're getting 2 volts, which is 2 octaves worth of pitches in the 1 volt per octave standard. Because we have the bass alto treble switch set to bass, when it's very low like this, it's kind of hard to hear. So let's turn it to the alto setting. We'll be able to hear the voice better. Now let's move over to the loop beats. This is a randomly generated melody, so on every 16th note we get a different CV value, but if we engage the loop beats, then it will actually repeat the same phrase over and over. So it'll generate 4 steps worth of randomness, and it'll keep playing that forever. But we'll reseed the randomness to create variations in a bit. Let's continue on to the quantizer. And let's set this to the natural minor scale. So we have pitches that are sounding more musical and not so random. And then finally, we're going to use the cross operation. We're going to set it to seed. And let's use the 7th output here. What this is going to do is it's going to listen to the output on the 7th jack, and whenever that is high, it's going to reset the randomness so that we get a new pattern. I talked about this technique in more detail on my video about the 8-bar rule with Pamela's Pro Workout. If you're interested in that, go check out that video after this. Let's skip over to our 7th output now and set that up. I'm going to change this to a divided by 32 multiplier, which is 8 bars. So we're going to loop the same measures worth of random pitch material for 8 bars and then reseed with that cross operation. I want to program the 6th output for the pitch for Incus Heterosocilia, and I want it to follow exactly the same pitch sequence as Basimulis because we're going to treat this as one big stereo voice. Now, because it's the same sequence, we could technically use a multiple again to just patch the same signal to both. But with a pitch signal, it's very sensitive to slight voltage differences in playing the same pitch. Maybe it doesn't matter so much in something like this where the pitch is not really the core of what we want. But just to show you the technique of how we can do this with 2 different outputs of Pamela's workout, we're going to give 2 different signals that follow the same CV values. So I'm going to patch the 6th output into the pitch of Incus Heterosocilia. And you can hear that we have kind of what we had before, where it's just alternating between 0 and 5 volts. So we get this back and forth of 2 pitches. I'm going to set the clock to 4x, just like output 5. So it's playing at the same rate, but we're going to use the cross operations to make the CV value that's sent out at every step match exactly. So we're going to skip over to cross op. I'm going to set the operation to min, and I'm going to set the source of that operation to output 5. Let's go into the alto mode on Incus. And you should hear now that they're both playing the same thing. The way this works is that the cross operation will cause a logical comparison between the signal on the 5th and the 6th output, and it will select the lower of the 2 voltages at every step. Because the signal on the 6th output is programmed to just be either 0 or 5 volts, then the lower of the 2 will always be the value on the 5th output, and so we essentially have a copy of the same thing. We have output 8 free still, and we can use that for modulation. So let's go over to the 8th output. Let's set it to a slower division and something that's not an exact multiple of 4. So maybe divided by 14. Let's go into the settings, and let's change the shape of that wave to a triangle. And let's reduce the level of the signal to maybe 25%. So the strength of the voltage is not too extreme, and you can use it for a more subtle modulation. And let's use that to modulate something on Electus Versio, maybe the tone control, which will sort of accentuate the higher or lower frequencies. So I'm going to set the tone right in the middle, which is kind of the default setting. And then this slow LFO from the 8th output of Pamela's Pro Workout will slowly modulate this tone knob back and forth to accentuate the low and the high frequencies. Okay, now let's get to the fun stuff, which is the modulation of our 2 oscillators. So I'm going to take all 4 outputs of Mimetic Digitalis, and I'm going to plug those into the 4 inputs of Lapsus Os, which is our performance attenuator. Lapsus Os can attenuate or invert, and in this case we just want to attenuate. We're getting a unipolar 0 to 5 volt voltage from the channels on Mimetic. And with these sliders at the bottom position, none of that signal is being let through. But if we move the sliders up, you can see the little LEDs on the sliders are giving you a visual indication of the amount of voltage that's passing through when they're fully open. Mimetic is also great because it has 2 identical outputs for each channel, so it's like a built-in multiple. You can copy the same signal to 2 destinations, and we're going to use that to our advantage because these 2 Alia oscillators have controls that are roughly analogous to each other. So on the first channel of Lapsus Os, we're going to send the modulation signal to the harmonics input on Basimulis and the alloy input on Incus Heterosocilia, which is kind of the core of how much of its internal oscillators are contributing to the signal. The second channel, we're going to patch into spread on Basimulis, which is the detuning of those internal oscillators, and weight on Incus, which is its rough equivalent. On the third channel, we're going to plug it into morph on Basimulis, which is the wave shape of its internal oscillators. And and the second copy to shape on Incus, which is its equivalent. And finally, our fourth channel, we're going to patch to fold, which is the famous noise engineering wavefolder, on Bassimilus, and temper on Incus, which is its equivalent. So now if we bring up these attenuators, we'll hear that they have a dramatic effect on the sound from these oscillators. We're going to get a new random pitch sequence from Hamlet's Pro Workout every 8 bars, but the modulation sequences coming from Mimetic Digitalis do not change automatically. And so that's going to be part of what we perform. Anytime we want the modulation signals to change, we can use a function on Mimetic called shred. There's a button called shred here that will randomize the CV value of whatever step is currently active, but if you hold the load button down and press shred, it's going to randomize the CV values for all 16 steps at the same moment. And it's because I have all 4 channels engaged, it's going to do that across all 4 channels. So every time I hold load and press shred, we're getting an entirely new modulation sequence for all 4 of our modulation channels. Let's bring up all the attenuators so we can really hear this. So we're going to get significant timbral changes every time I shred. The modulation from Mimetic is patched to both oscillators through Lapsus Os. So if I shred the pattern or if I move any of the sliders on Lapsus, it's going to change both oscillators. But of course, we still have all of the controls on each of the oscillators that we can use to affect them differently. These become the offset to which the modulation coming in is applied. And you'll notice that I have not patched modulation signals to the attack and decay controls for each, so we can control those separately too. And this determines how long a note rings out after a trigger comes in and how long it takes to ramp up to its full volume. We can also modulate Electus by hand. For example, turning the dense knob all the way counterclockwise will give us more of a delay rather than a reverb, and we can use the size knob as a clock multiple of the incoming clock. It also has its own built-in modulation source, which is the speed and index control. The speed is the rate of the internal LFO, and the index is how much that is applied to the delay signal that is the basis of the reverb. Turning clockwise will give us a sine wave LFO, and turning counterclockwise will give us a random one. So that's it, and we just have fun performing by resetting the random pattern on Mimetic, by changing the attenuation of those modulation signals on Lapsus Os, and by affecting the controls on the Alia and Versio modules directly. I hope you enjoyed this, and I hope it gave you some ideas about how to put together a small system of your own for some fun techno jamming. If you found the video useful, I hope you'll subscribe to the channel for more videos like it. I would also very much appreciate your support on Patreon. You can join for free for updates about new videos and live streams, or chip in a few dollars a month for a bunch of benefits, like patch notes and project files for educational videos like this one, high-quality audio downloads of music from the channel, sample packs, full access to the community Discord server, and more. If you want to pick up a small modular case, or any of the modules I'm using here, you can also support my work by purchasing from Perfect Circuit using the link in the video description or the pinned comment. This will earn a small commission for me at no additional cost to you. Thank you so much for watching. I'll see you next time.